This is Group 3's video presentation of the soft robot, and it is done by Ashley, Siu, Bhavesh, Ryan and Gabriel. Let's start with the individual experiments. To start off, we wanted to measure the maximum deformation, or extension of the robot. To do so, we used image J to measure each image taken. These images were scaled using the ruler that was captured together with the robot to improve accuracy. The length of the full extension is then calculated and reported in the results table. This process was then repeated a few more times to achieve a maximum and average extension of 18.71. Next, we wanted to characterize the contraction of the robot and verify the repeatability under identical pressure inputs. Images were also taken at a 90-degree angle to reduce parallax error. And following the previous test, the scale is set according to the ruler captured in the image to improve accuracy. Once completed, a line will be drawn through the robot to measure and record the contraction of it. This test is then repeated about 5 times, which allowed us to obtain a minimum deformation of 16.51. And since the surgical obstacle course contained multiple turns, to evaluate the robot's inherent turning capabilities, we tested and measured the robot's directional flexibility using the tracker software. We concluded that it has maximum bending angle of 13.9 degrees. We also compared 2 different pumps. The pump with a higher power of 8 watts was able to maintain suction as compared to the lower wattage. Moving on to the final testing phase, where we place the robot to navigate through the surgical obstacle course, or SOC. The soft robot will travel to the first T-joint, where the operator will give the command through the Arduino software for it to turn left or right. This will cause the pouch motors mounted on the left and right sides to expand, which provides the necessary asymmetric expansion that the bellow body alone could not achieve. In this case, the operator chose for the robot to turn left, which causes the pouch motor on the right to be pressurized, which induce bending to the left. In this section, you can see that the robot has cleared the first T-joint and is moving through checkpoint 1 of the SOC. This is also achieved by the operator's input for the robot to turn right. This input will pressurize the left pouch motor, which induces bending to the right. Lastly, the soft robot would need to navigate through the second T-joint by turning left. This leads the robot to an S-course, which is checkpoint 2. After the S-course, the robot will proceed with clearing checkpoint 3, an object retrieval task. This is the end of the demonstration. Thank you.